So tonight we're probably going to do about 35-ish, 40 minutes, and I want to talk about rigid motions because although these aren't tremendously difficult, they are definitely one of the most important topics that we'll talk about in the course, and they're going to come up again and again and again on your Regents. If you don't use the phrase rigid motion at least once on your Regents, I think something has gone awry, and I think most of your teachers would agree with that, even if that teacher is not me. So we're going to start with some more basic ones. What are they? Doing them on the coordinate plane, and then we're going to move to describing them off the coordinate plane, because that tends to be where people struggle the most. So, we're going to start with, well, what is a rigid motion? So there are 4 rigid motions, technically 3, and then one's a combo of 2. Some people define it as its own, that we talk about in geometry. And rigid motion, the reason that they're called that is because rigid motions preserve distance, meaning they don't change side length, they don't change distance between points, anything like that, and angle measure. So if an angle is 30 degrees, that is not an M, but we're going to go with it. If an angle is 30 degrees, when you perform a rigid motion, it will stay 30 degrees. If a segment is 5 centimeters, when you perform the rigid motion, it will stay 5 centimeters. So rigid motions preserve those. Because of that, this makes the pre-image and the image congruent. So our definition of congruent at the beginning of the year wasn't just same size, same shape. It was that there is a rigid motion or a series of rigid motions that maps one onto the other. And that's really what makes something congruent. And that's an explanation that we're going to use definitely on our Regents in some questions. So 4 rigid motions, really 3 main, and then 1 is a combo. A translation, a reflection, a rotation, and a glide reflection, which is a combination of translations and reflections. Glide and reflect, right? So the important things to remember, and again, we'll talk about this more, a translation is a slide, and it is always along a vector, and the vector will connect corresponding points. Vectors are directed, so they have a direction to them. There is a pre-image and an image. A reflection is always a flip over a particular line or a particular segment, and you can always figure out that line by connecting corresponding points and then bisecting it, right? So if I actually connect each of these pairs of corresponding points, this line of reflection is the perpendicular bisector of those. A rotation goes around a center point, so if I connect 2 corresponding points to the center, this angle would be my angle of rotation. Rotations have a center, rotations have a direction, and rotations have an amount, an angle. And then a glide reflection is a combination of those. So in this case, we reflect, and then we translate, and that's a glide reflection. So you're going to see combinations of those as far as rigid motions. So we're going to start kind of small, and we'll work our way up. Almost everything we're doing here are Regents questions, and some of them, will kind of build us up to some more Regents questions. So we're going to start with some multiple choice and just identifying transformations that have occurred, especially when we start talking about changes in orientation. That can become more difficult for people. So if you have questions as we're working, send them in. I love seeing all the people that are on with me live, and if you're watching on the replay, that's fine. Feel free to ask questions even then. So in this diagram, A prime, B prime, C prime is a transformation of ABC, and A double prime, B double prime, C double prime is a transformation of A prime, B prime, C prime. The transformation is an example of what? So the first thing you want to identify here is, what is your initial, right? So my initial is the one without the primes. Then I'm going to the one with primes. Then I'm going to the one with double primes. And so that's what I'm really looking for. The first thing I'm going to look at here is my orientation. And I know some of us just see this, but some of us struggle a little bit more to see it. So we're going to start small and we'll work our way to harder things. So if I go from C to B to A, I'm going around that way, right? And I'm going to look at this prime and C to B to A. Well, that's the same thing. So that orientation got preserved. If it was a reflection, orientation would be flipped. So this orientation got preserved. I see that this looks like it was just a slide. So I see that point A looks like it slid to here, point B looks like it slid to here, point C looks like it slid to here. Notice all of those vectors are parallel, right? That is a true sign that this was a translation. So I know that this translated along those vectors. And then when I look at this, well, B is here, B prime is there, B double prime is there, A prime is there, A double prime is there, C prime is there, C double prime is there. It looks like it just got flipped over the y-axis. So what I would say happened here is, first of all, a translation. So it's not going to be 1 or 2 because I see that the translation happened first. And then a reflection. It flipped over. So I would say on this, it was number 4. All right, I'm going to continue on. Again, send questions if you guys have them. So in this figure below, figure 1, 2, and 3 are drawn. What sequence would map 1 to 2 and then 2 to 3? So they numbered them here for us. So let's start with this. Let's look at orientation. So I go A, B, C, D, E, F. I go A, B, C, D, E, F. So this was not a reflection. Orientation was preserved. So I'm going to look and make sure that I've got some parallel vectors when I connect my corresponding points. I do. All of those vectors are parallel. So that's a translation. So first thing was a translation. So again, not 1 or 2. Now I'm going to look at what happened here. So I can see that definitely this didn't just flip, or it appears to not just flip. But I can also look at my orientation here. So I go A to B to C to D, right? That's the way it's going when I go clockwise. So if I go here, A to B to C to D, I'm also going clockwise. So I can see there that my orientation didn't change, right? And so that's how I know this was not a reflection. This was, in fact, a rotation. And so I'm going to go with 4. Again, these aren't hard for some people. Some people struggle to see it. So we're starting small. We'll get harder. All right, let's go to the next one. A sequence of transformations maps the first to the second and then to the third. What would be this sequence? So this is 1, this is 2, this is 3. And here's where we need to be very careful. A lot of people will look at this and go, ooh, this just translated, right? These are all parallel. This just translated. So what we need to really look at here is the orientation. So if I go clockwise, I go A to B to C to D, right? On this one, if I go A to B to C to D, I go counterclockwise. I see here that my orientation actually changed. So this flipped. And if it flipped, I automatically know that that means that I had a rotation. Or a reflection, sorry. The other way I know is because, look, D is closest here, D is closest there. It didn't just slide, right? A would be on the top if it just slid. So A is on the outside, A is on the outside out here. So it actually physically flipped over the x-axis. The other way I know where that line is D is 4 away, D prime is 4 away. So it needs to be symmetric on either side of that. So I know that first thing was a reflection. So it's not 3 or 4. Then I can pretty clearly see that this turned, right? And so this is going to be a rotation. So always look for that orientation and always look for, did my points actually flip or did they just slide, right? That's important. Okay, so the number 5 is here. What happened to these? A sequence of transformation. What would map triangle ABC onto DEF? So this is 1 and this is 2. And here's what we really need to be careful about here is being very precise with what we're saying. So the first one, answer choice 1, says a reflection over the x and then a reflection over the y. And notice here that I want A to map to D. So A should map to D. B should map to E. And C should map to F. And I'm just looking at the actual order of the letters. So A is first, D is first, B is first, E is first, C is first, F is first. So let's see what actually happens. If I reflect over the x-axis and then reflect over the y. So reflecting over the x-axis, A prime would be there, B prime would be there, C prime would be there. And then if I reflect over the y-axis, so that would be A prime, C prime, B prime. So A double prime would be here, B double prime would be here, C double prime would be here. So let's see if that preserves the mapping that we want. Does A map to D? Yes, it does, right? Does B map to E? Yes, it does. Does C map to F? Yes, it does. So I see that that mapping is preserved, so that's how I know that it is this. So again, if you're unsure, try them and see which one actually works. All right, the next one's very similar. What I would say here is there's more than one right answer here. So let's think about this. What could have happened here, if I actually look at my orientation, I know that this flipped, right? So it could have flipped and then translate it over. So it could be a reflection and then a translation, which would be C. It's not a reflection and a reflection. There's definitely a translation. It's not a dilation and a rotation that didn't change size. And on this one, well, what if it translated first? So that's the only thing I would say. So what if this translated first, but then it would still have to flip, right? It would still have to flip over that line. It wouldn't just be rotating, because if we actually look at it, A should map to A, E should map to E, D should map to D. So it is not a rotation, which makes it not 2, because the orientation actually changed. Okay, so again, there's a bunch more on here that are very similar. We'll maybe do one more, and then we're going to move to some off the coordinate plane, because I know for a lot of people that tends to be hard. So let's look at, how about these 2? We'll do 2 of them. So here is a set of triangles. I want ABC to map to DEF. So ABC, this is my first one. DEF, that's my second one. And sometimes the best thing you can do on these is actually try, right? Actually try them and see what works. So the first thing that I'm going to try, I see that it looks like this got slid over. So let's try that. Let's try sliding it over. So, okay, D is here, so maybe I want A to map to there, right? So A would map to there. So that is a translation, 1, 2, 3, 4, 5, 6 units to the right. So I'm going to say maybe we translated 6 right, and let's see if that holds. So let's map that translation. So A would translate to here, that would be A prime. B would translate to here, and C would translate to here. So that's A prime, B prime, C prime. Now we want to see, well, what would happen next. So I see A should map to D, B should map to E, C should map to F. Let's check and see if that's actually symmetric, because it looks like it just flipped over the x-axis. So if it's symmetric, then that's what we went over. So A is 3 away, D is 3 away. Same for B. And then this is the same distance as that. So as long as those are symmetric, that's your reflection. So it translated 6 to the right, and then it reflected over the x-axis. There are other ways to write that. You could write it in notation. Like, for instance, we could say translate 6 right as x plus 6 and then y, right? So we could say xy maps to x plus 6y. We could say reflection over the x-axis as our x-axis. But I would say if you're in doubt, write them out in words. It's going to be your safest bet, and you'll get full credit. That's fine. Now, notice I didn't include a mapping on this. You could say so A maps to A prime, and then so A prime maps to D. But because I'm talking about on a coordinate plane, it's not as vital here because I can specify the amount something moves. Okay? All right, let's try one more. So, let's see. Let's do this one. So I want to map A, B, C to A double prime, B double prime, C double prime, and I want the rigid motions that would do that. So this is 1, and this is really going to be 3 because we need to go to A prime and B prime and C prime first. So the first thing I'm going to do is kind of translate it. So I'm going to move down 2 for each of these because that's going to at least kind of map these onto the same horizontal line. So I'm going to translate down 2. Now, I see that those are 4 away. The middle would be right there. Those are 8 away. The middle would be right there. The same holds for B prime, so I'm just labeling these. And so my line of reflection here is the y-axis. So I'm going to then reflect over the y-axis. And again, specify there, or you could say xy maps to x, y minus 2. You could say followed by our y-axis. But again, if you don't need to write it in notation, don't, right? I would prefer that you specify what you actually know how to do. Stuff in notation to say you wrote it in notation. Can we go over a pentagon one again? Sure. So again, if you have questions, send them back. I'm going to go back up to the pentagon one. And then we'll go down to some off the coordinate plane because that tends to be what's harder. So on this one, I want to know, well, what happens? What maps to what? To the pentagon. So, okay, first thing I'm going to look at is, well, it definitely looks like it flipped over, right? So I know there's going to be some kind of reflection. So you could eliminate any one that doesn't have reflection. So it's definitely not 1. It's definitely not 2. So now I want to see, okay, well, was it a translation or was it 2 reflections? So if this was a reflection, let's say that this reflected over a line here, that would go like this. And we would have A prime, B prime, C prime, E prime, D prime. Right? So I know that's a reflection. So let's see, did it reflect again or did it translate? If it translated, then A should map to A, which, okay. B should map to B. They should stay on the side of the shape that they are. C should map to C. D should map to, I flipped these, didn't I? Yeah, that should be E prime. And that should be D prime. E should map to E. And D should map to D. And as long as it doesn't look like it flips again, right, it's just a straight slide over for each one, then that's how I know that this is just a translation. Because we could draw vectors connecting each one, and there wouldn't be any like mix-ups, there wouldn't be any that don't look like they just slid. These all look like vectors that slid the same amount. So it just flipped and then slid over. Okay, so let's move to some off the coordinate plane because this tends to be where people struggle, okay? This tends to be where people struggle. And again, send questions as you have them. This is what our tip on the GeoChat was about tonight. So if you got this tip, this is a great reminder for you. So start with a reflection, okay? When you talk about a reflection, the things you're going to want to mention here are you're going to want to talk about first the pre-image, right? So you're going to want to talk about reflecting blank, the pre-image, over blank, the line of reflection, okay? Until, or so that, or so blank maps to blank, okay? So the things you need with a reflection are a line of reflection. That's really the big thing. You need to reflect over a line. You still want the mapping, you still want the pre-image and the image. And the other thing I would say is if they don't give you the line, remember the line of reflection is always the perp bisector of 2 corresponding points. Okay, and I'll show you what I mean by that. So if I choose any 2 corresponding points, like here C and C prime are connected, that will be the perp bisector of that segment. Okay, same thing for here, B to B prime, perpendicular bisector of those. So if they didn't tell you the line of reflection, you could say over the perpendicular bisector of C, C prime. Somebody just said, when should you use vectors in your answer? That's what we're about to get to when you're off a coordinate plane. It's not wrong if you use them on the coordinate plane, but you don't need them there because you can specify the amount. Okay, so rotation. Let's talk rotation. So I want to say rotates, and then the pre-image, right? Then the direction, clockwise or counterclockwise, about point blank, your center, until blank maps to blank. So here's what you need for a rotation, okay? You need a center, often forgotten. You need a direction, and you need a mapping, as you would for any. The big caution I would give you about rotations is if it is not clear what the angle is, do not try to make up an angle. You do not have a protractor on the regents. Do not make up an angle because, oh, it looks like 90 degrees, right? If it's not clear what the angle is, if it's not labeled or it's not on a coordinate plane where you can just say 90, Do not make up an angle. That's how you wind up being wrong, okay? All right, last one. Vector question. This is for you. Translation. A translation is always going to be along a vector. So I would say translates a preimage, blank, along vector, blank, until blank maps to blank, okay? So translate along a vector until blank maps to blank. That's your goal here. Vectors should always connect corresponding points. So if this is L and this is L prime, it should be starting at the preimage. So translation, connect your corresponding points, and that's when you want your vector. So let's do a couple of these, okay? So let's look at this one. So I'm taking this and I want to describe the rigid motion that happened here. It's pretty clear to me that there was a reflection, right? It looks like this just flipped over. The line of reflection here is right there. So here's what I could say, okay? I could say this was a reflection of triangle ABC, the preimage, over segment BC, right? A reflection over that segment, so that, or until, or whatever, A maps to A prime. That's one way I could say that, because this is flipping over that segment, so A maps to A prime. Now, the other way you could say it, you could say the same thing, a reflection of triangle ABC over, and now this would be maybe if they didn't give you the name of that segment, the perpendicular bisector of A prime, that segment, so that or until A maps to A prime. Okay, so that's one way to do that mapping. All right, continue to send questions if you have them. Let's do another one. Rotation, the most missed. So what happened here? Well, I can see that this turned, right? So the first thing I want to know is, well, what did it turn around? So look at the stationary point. So B is my center. Okay, B is my center. Now, I see that it rotated this way because C and C prime are corresponding, and that is clockwise. So here's what I'm going to say. Rotates triangle ABC clockwise about or around point B until C maps to C prime or A maps to A prime, whatever. The thing that you don't want to do here is say, oh, that's about 80 degrees. Because the mapping is what tells me how far to go. It says rotate until they're mapped onto each other. Once they're mapped, you can stop. So you don't need the angle because the mapping will tell you. Okay, let's do another one. So let's look at this one. So what happened here? Well, this looks like maybe a reflection, maybe a rotation, maybe a combination. So there's kind of two things you could do here. If you actually wanted to do a construction, you could connect CC prime, connect AA prime. You could bisect those. And if those come out to be the same perpendicular bisector, you could say that that was your line of reflection. But if you don't want to do that, let's talk about another way to do it. So first thing I would do is I would say, well, let's rotate this. Let's take this shape and let's rotate it so that we get those matching up. Then once it's rotated, we could just flip it over and reflect it. So what I could say here is rotate triangle ABC clockwise about point B until, and pick a mapping, C maps to C prime. So that would give me here. Now I would need to reflect it, right? Now I would need to reflect it. So I could say then reflect over, well, what did it reflect over? My line of reflection would be BC, right? That's what it flips over. Or sorry, B prime, C prime. Until A maps to A prime. So if more than one thing happens, just say more than one and don't make more work for yourself unless you clearly see you could do a construction and you could name that line. All right, let's do another one. So here's another one, and it's pretty clear what goes on here, but let's make sure we can describe it. So first thing I see is this is my original, no primes. This is my second one. Well, that looks like it flipped. And this is my third one, which looks like it maybe rotated. So let's start with the reflection. So I'm going to say reflect, triangle, ABC, over, and notice this is line L. So you could say line L, or the perpendicular bisector of A prime or AD or BB prime or whatever until, pick a mapping, C maps to C prime, right? Then rotates triangle A prime, B prime, C prime. Rotate triangle A prime, B prime, C prime clockwise, because it's going this way, about point D until, again, don't make up an angle measure, just say you're mapping, B prime maps to E. So the first thing I would always do, again, is if you can translate, try it, if it's clear what that is, if you can rotate until sides are together and then reflect. So let's do like two more and then I'll wait around for questions and then we'll be out of here for tonight, okay? Then we'll be out of here. So let's look at these. So I want to do this. I want to describe the transformation. So I'm going to start always by translating whatever I can, okay? So I'm going to say, all right, I think that C should translate over to C prime. That's the first thing I want to look for is, can I translate? Okay, get some corresponding points together. So I'm going to say let's go the right way, Mrs. G. Go C to C prime, not C prime to C. So translate triangle ABC along vector C, C prime, C, C prime, you could do A prime, B prime, doesn't matter. Until C maps to C prime. So let's get a feel for what that looks like. That would mean taking this triangle and just sliding it over until that matches up. Then, okay, so that's C prime, this would be A, this would be B. Again, those are kind of like ghost values. And then I'm going to rotate this that way. So now I'm going to rotate clockwise about C prime until, and then pick a point. A maps to A prime or B maps to B prime or whatever. And that's it. That would get you full credit. You could also do a construction here, but you don't have to. All right, let's try one more. Let's do, actually, we'll do both. All right, let's try this one. So let's just do this one. That one's pretty similar. Okay, this bottom one. So first thing I'm going to do is translate so my corresponding points are together. So I'm going to go B to B prime, okay? So I'm going to translate a long vector B prime, until B maps to B prime. So that gets me over here. So I'm going to draw this shape, sort of. So translate this way. Okay. Then I'm going to say I'm going to rotate this so that those sides match up. So then I'm going to take this and I'm going to kind of rotate it so those sides match up. So then I'm going to rotate. That's counterclockwise, right? About B prime until A maps to A prime. So now we've got A prime mapped, we've got B prime mapped. Now I need C prime map, and look how that happens. This flips over to here, okay? So then I would reflect over segments A prime, B prime until C maps to C prime. So if you draw the intermediate steps there, it can be a little bit easier because at least you can see what's happening and kind of predicts your next move. If I say give me a sequence of rigid motions and somebody does it in 1, that's fine. Somebody else does it in 3, that's fine. Remember in my class when we played transformation mini golf, sometimes it took multiple transformations. Some people did it in 1 step, some people did it in 7. As long as you get there, I don't care. I just care that you get there. Okay. So that was about 40 minutes. I'm going to hang out, answer any last questions. I'm sorry the feed cut out. I will make sure that does not happen again. Normally Mr. G and I will not live stream at the same time. But because of that, you guys got to see some new scenery. So I was not in my office. So I'm going to hang out for questions. Please send them. Go over the one above the question we just did again, the scenario 1. Yes. All right. So we're going to go over this one more time, because that's the one we were talking about. So, the first thing I'm going to do here is I'm going to translate some corresponding points together. So I chose C and C prime because those correspond. So I made a vector that connects them, and I said translate A, B, C along that vector. So that was going from here to there. So just sliding over, right? Once I have that point mapped, I see that all that really happens up, so one maps on top of the other. So that's a rotation clockwise, about point C, that's your center, until point A is mapped up to A prime. So let me actually rotate this for you. So it would look like this. I would keep point C still, and this would rotate up to there. Again, that's kind of hard to show on this, but rotate down, rotate up. So rotate up to there. And point C should be staying still. I just am not great with my iPad. Okay, what other questions? What else can I go over? What else can I do? What other questions do you have about this? Make you guys stare at my dog until someone sends a question. It's pretty cute. Harper, you want to say hi? You want to say hi? Yeah, not really? Okay. Anything else? What can I answer? All right, we'll do this again Thursday. We'll pick another topic. I will let you guys know more in our reminds over the next couple days, but send me any other questions. And thank you for watching. Have an awesome night, guys. You rock.